Okay, we're going to go ahead and get started then. So welcome everyone. As you can see, my talk is titled Off the Beaten Path, An Explorer's Guide to Kubernetes. I actually was influenced by that title by one of my coworkers because that's how he described what we were doing with some of the stuff we're trying to figure out inside of Kubernetes. But my name's Terry Thomas. I'm a cloud software engineer at Intel. I work with our continuous integration, continuous delivery pipeline on Kubernetes, of course. Some direct work with Kubernetes and also the Snap telemetry framework, which I'll explain in a second. And I'm one of the meetup organizers for the Docker meetup in Portland. And I'm also a home automation amateur, much to the annoyance of my wife a lot of times, and a hiker. And if you want to see some of the other stuff I do, there's my Twitter and GitHub handles. So I just want to give an overview of what I'm going to try to go over here and the goal of what we're going over. So just as a note, this is for intermediate to advanced users of Kubernetes. I'm expecting that you've used it and have an idea of what the different objects are and how to use them. If you're not at that point, you'll still probably get some stuff out of this, but I'm going to be digging pretty deep into different code examples of how we're setting this up. So basically, we all know that Kubernetes is really easy to kind of just show off your cool cat blog with an Nginx server, but once you start going down into the bowels of an application and trying to get real production applications running, it becomes a lot more difficult because you have to handle configuration, monitoring, application cycle management, all those different parts of an application. So I've organized this to kind of follow the journey we took and to show the examples of what we had to figure out along the way. So we'll go through what we're doing as a team and what my team's doing right now, how we started it out, then that question of things work, now what? And then are the things actually working? And then how we tested everything, and a note about documentation. So just a note about what we're doing. We are still in a nascent stage in terms of like size, but we have about 17 different repos. That goes up about once every 2 weeks because of all the plugins that we use with Snap. All the different Kubernetes applications we test on Jenkins before we deploy them. We have about 32 jobs a day. That was about 2 weeks ago, so it's probably gone up since then. That goes up quite often. And then we have a CI/CD system that has to be able to run bare metal tests, VMs, and containers for unit tests or large integration tests between different parts of an application. We're also running Cassandra to save different data sets from some of the other projects that we're working on. And we do a lot of our telemetry gathering with Snap. Now, just a quick overview of what Snap is. If you want to find out the full details, you can come talk to one of us at the Intel booth or talk to really anyone here from Intel right now. But Snap is a really cool tool that makes data gathering really easy. Instead of it being very specific to a specific type of data, it puts an abstract interface in front of it where it'll expose all of the metrics a machine can get, whether those be application metrics, CPU metrics, memory, or things like Docker statistics. And so Snap is a tool that we use for monitoring in Kubernetes, and I'll show how we use that later. So as I said in the beginning, we're going to go over why we chose Kubernetes, some things about configuration, using the Kubernetes API, volumes, containers, and technical debt. And so the question why we chose Kubernetes, it's actually really interesting to see why people chose to use Kubernetes, because most of us are here because we're either using it or interested in it. So I'm not like trying to convince anybody. I'm just giving the reason why we did it. So the thing that really got us for it was we can iterate and deploy quickly. Now that took some work to get to. It's not something magical that happens when you start in Kubernetes. But once you have it up and running, we can deploy things very quickly. It also allows you some really fine-grained control of your applications. If you were here for the last presentation, we talked a little bit about the scheduling resources and things. I mean, you can get some very fine-grained, detailed tweaking of your applications in Kubernetes, and the different API objects are very logical. So it also is just really, when I talk about fast spin-up speeds here, I'm talking like we can spin up Cassandra or Jenkins in about 2 minutes. A minute to 2 minutes. So it's a really quick process once we get it all set up. So first thing, configuration. Now we had to set up Jenkins. Now, just out of curiosity, how many of you have set up or configured a Jenkins server? Okay, yeah, that's what I thought. Okay, so it's a little complex. Like this, or maybe this, or this one. That's not even the whole slide. Like I could keep going for about 3 or 4 more. I think I tried just guessing based on how much I was grabbing. And that doesn't even include all of the security settings or any of that other stuff you have to configure for Jenkins to work. And so how do we solve this in our case? So we had to use the Kubernetes API. I'm going to explain a little bit about what we did with Jenkins and some of the other things we did as well. So the issue we ran into with Jenkins is that to bootstrap things in Jenkins, we have to have passwords. So we use GitHub OAuth. We need an OAuth token. We need a password to be able to access repos. We need a private key. And you can't just shove that stuff around really easily in Jenkins. You can't just set it to an environment variable or that you have to have it in a config. And so we really couldn't do it just by putting in a config map or a secret. And so we had to use a bootstrapping script, which I'll show how we did that, to get all those things set up. We also had to use it to get information in Snap, because Snap, when it's running in the daemon set, to gather all the data, it's running on a host network. And if you haven't ran into this before, if you have something running on a host network, it can't resolve the DNS address of services. So we had to use the API to get those. So let me just explain how we did that. So with tokens, this is a lot of code. I have my slides up on there so you can look at it, but I also have some snippets that you can access online later. But the first section up at the top, the blue code, basically every single pod inside of, or every single container inside of a pod has tokens mounted by Kubernetes inside of it at the var run secrets kubernetes.io service account. Inside of there you have a token, namespace that the pod is in, and a certificate bundle. So we, in our case, just grab that token straight from the file system in there and then use the environment variables that are set inside of a container as well. The big ones to know in this case are the Kubernetes service host and the Kubernetes port which it's listening on. In this case, ours is running, I think, just the default 443. But if you're running a custom setup or configuration of it, that port will be correct. And so then we just use that to create the proper string for what we're doing to call the API. So once we do that, we set up the connection, and the next big part is the green line, where we have the add request property. This is where you add the authorization header with that token. So it allows you to do just a basic HTTP call using that token. You just have to make sure you put it in the proper header so that it actually works for you. And in case you're interested in doing this in Jenkins, I also included that. That's right down here. I have, once again, full code snippets online, but you basically have something called a username, password, credentials implementation. You have one of those for private key and a bunch of other stuff, but you can set the ID, which I just set to blah, blah, and then the username and password, which I got out from the JSON response from the API. And so that was the first use we had of it. Now, using those tokens are very helpful in case you have to do some custom configuration or setting a value in the API or retrieving a value from the API. The next thing is the Go library. So as I said, with Snap, we couldn't resolve the Snap service IP address. And so what we did instead is we had to go grab all of this. We grabbed the services from the API. Now, this is just this is like the first version. We could have filtered it, because you can see in that green line right there that all you have to do is do a label selector, and you can actually select the service you're looking for using that label. But creating a client is really easy, because the Go library knows to look for the tokens in that directory that I was talking about earlier. So all you have to do is client.new in cluster, and you can connect straight up to the API. And in our case, we were able to just look for the service and then access the service IP address and set that as the IP address that Snap needed to connect to get everything bootstrapped and set up. So it's very useful if your code is already in Go, like we had here, but if it's not in Go, there's other options like I was showing before. Now, the last one is you can also install kubectl or kubectl. You pick your poison of how you want to say that. And this is actually very helpful as well, because it knows where to look for the tokens as well inside of that same directory. And so we use this for our proxy. We use agents inside of Jenkins that actually act as a proxy into the cluster to run tests. And I'll show a running example of that. But basically, you can just run any kubectl command like you would from your developer laptop or wherever it's running from, just by installing the binary into the container. So the next thing, volumes. Now, volumes, the first thing we learned about this is that lots of different things can be volumes. Config maps and secrets are very similar in how they behave when they're mounted. You can also mount different types of persistent disks. And a couple different things with that. So a lot of times when you just mount a config map, if you have multiple keys inside that config map, it's going to mount each key as its own file. If you want to map only one of those keys as a file or specific ones, you can actually pass what's in that top example of an items array. And the items array can contain the key that you're looking for, and you can actually rename what that file is going to be called inside of the container. In our case, this is for our Jenkins, and so we renamed the config key to config.xml so knew it would be an XML type. Then read it in the Jenkins startup process. Now also, one thing I didn't include here, but this is a very recent addition to 1.4, so if you're on 1.4 now, you can take advantage of it. One of the problems that we've had was that when you're setting, especially secrets, like key values inside of a container, it doesn't work unless it has a permission set of 600. And so you can actually do that now. Before you couldn't. So there's two ways to do it. The first one is you can give a default mode to every single file in the config map. That goes at the same level as name and items. And so if you put a default mode in there, you can say default mode 600, and everything will be 600. If you want to set it individually, you have to go and break everything out into the items array. And so inside of items, there's a mode key that would go right there, and you can say that's 600. So that's actually really new. It rolled out with 1.4 just recently. Now, there can be problems when you're trying to mount some of these config maps in the same directory. In our case, there's a key called subpath that allows you to do it, but in Jenkins at least, it doesn't like that very much. It tries to think that it thinks the file has a lock on it for some reason, which we're still troubleshooting. But just be careful when you're putting things in the same directory, and be aware that you might have to have some workarounds. In our case, we had to just do a dead symlink that points to the location where we're mounting the volume using Kubernetes. So that's just a couple of the gotchas for you. If you see any others, it's really good to document them so people know what's going on. Okay, so just a couple words about containers. This is the Cloud Native conference here, and that has a lot to do with how we build containers. And we learned a bunch of different lessons from building Jenkins, Snap, and Cassandra for working inside of a container orchestration system like Kubernetes. And so first I'm going to go through some do's. Now just remember, a lot of these do's have a corollary don't that we learned from to learn how to do this properly. So the first thing, do allow external configuration. Now what I mean by that is that your container should allow you to set everything with a basic config file mounted somewhere, or through environment variables, preferably both. That's what we learned especially from Jenkins. Like, you can't have all this config have to be there pre-existing and then mount different values, and you just need to be able to configure them using environment variables. Another one, this one sometimes we missed, you just have to have sensible defaults when you're creating your images. In our case, these are things like basic security, timeouts, other values of the application startup. So timeouts in our case were for Jenkins and how much time it had to connect between different agents. We also had the idea of having a README. Now I'll show an example of what I mean by a README. This is a pod monitor we created that I'll show some of the code for later. But I wanted to show what we did. In this case, I've documented every single part of the config file and shown an example of the config file. So it has a description of what it's doing, if there's a default, and what the behavior is. Now, you will love to have this later down the road, because you'll leave it and just leave it sitting there for about 2 months, and then you'll come back and realize you want to change the configuration, have no idea how to do it. So make sure you have a README for all of the different containers you have and how to configure it. It's very helpful, and the best containers that you use out there have a very good README that you can find generally on Docker Hub or wherever you're storing your containers, and you can see exactly how to configure each of those. Another one is to remember is just, for the love of all that is holy, make it log. Okay, now I can't stress this enough. We have problems with things not logging right, or being able to change the logging level is a really painful process of setting, like Jenkins and Cassandra. You have to go in and set a different log at a command line flag and do a bunch of different configuration. Just make it log, and what I mean by good logging is this. Tell the user exactly what's going on, because this is how we troubleshoot. When you go at it, you first look at like probably kubectl describe pods, and then you look at kubectl logs. And right here, I can see exactly what, this one's the pod monitor I was talking about. I can see that there was no Slack webhook specified, so it's logging instead of sending it to Slack. It's starting a probe, it didn't find any errors, and how long it's waiting for. Same thing down here with another alerting tool we're using. It says how long it's sleeping for, what it queried, did it get results, were there any hits. So I know exactly what's going on inside of the container, and being able to configure that log level. Another thing is to remember it's okay to install the things you need. I am all for keeping your container images small. The 1 gigabyte monstrosities that all of us have done, let's be honest, we try to avoid those, but sometimes it is okay to install things so that it can spin up quickly in Kubernetes. Once again, this is one we learned a lot from Jenkins, and also from Snap in installing some of the things we did, is that if you try to let Jenkins install its plugins every single time it spins up, that's a lot of time, because Jenkins already takes a minute or 2 minutes to spin up by itself with plugins already installed. So adding something else on top of that, it's worth the hit for having a bigger image than trying to install those every time. So now on to some don'ts. So first thing is don't keep credentials in configs. What I mean by that is you should be able to specify credentials in a separate location outside of the config. So you shouldn't have to specify your password in the config file you have to mount. You should be able to specify, here's a file that contains the password. Or, like I said before, specify in an environment variable. Now, don't put stack traces in logs. This is to an extent. Obviously, if it crashes or there's some really serious unrecoverable error, stack traces are good. I didn't want to splat it up here because it's really hard to read, but we've had those, especially in Java applications, where it spits out the stack trace that goes on for like 2 pages. And there's 1 line of information I need in there, and then you try to throw that into Elasticsearch, and Elasticsearch's like, I don't know what this is, and there's 20 entries for that single thing that went on. That's not helpful. Now, having it when it crashes, it is, because then you can go back and debug and see what's going on. But if you do have to put in stack traces, try to keep them in debug mode unless they're absolutely critical to showing what happened when the application just died. Another thing is don't over-customize. We learned this really the hard way, just seeing how many things we added on, because then you have more layers that could fail on you. If you can use a default image and customize it just using the config, do that. It's much better than customizing. We started with actually a lot of customization to Jenkins. We've been slowly rolling that back as we have figured out how to do it with better methods. So just a note on technical debt. So really, as you're doing Kubernetes and spinning things up in it, you'll have to refactor things anyway, so it's okay to take on some technical debt. And you don't want to make it so hard to get started because you're worried about taking on technical debt. 2 examples that we did to get started was credential baking and token mounting. So like bad security practice is mounting credentials and putting credentials inside of a container. We took that hit for a little bit to get started because we had a secured container registry that was private, and it would allow us to spin it up and get going quicker. We've gone through, we've removed that, and we've been able to mount it, but it allowed us to get through, especially with Jenkins, just getting it started up. And so it's okay to take on technical debt like that. The other one, this is actually one that has a good code snippet along with it. For example, if you do not want to have a pod have access to the API, because that token that I talked about earlier is mounted by default in every single container. And sometimes you don't want that container to have access to the API. The only way around that right now, they're working on a solution for this, a better solution, but right now you can actually mount an empty volume there. That's a little hacky, but yeah, question?
You could also just remove rights from the default service token, right?
Yeah.
Account and user specify another.
Yeah, you could also specify another service account as the other one. It just depends on how you set it up. This one was just really easy to slap it on there and not have to worry about it. But that's one example of the technical debt we took on. So we got it working. And we all love this meme. It works fine in dev, right? But the problem is we do DevOps. So the problem is we are the ops people who just developed ourselves into a corner. So we got to this question of things work, now what? Like we had this, what did we do to ourselves? We had some problems to fix, and I won't go over those and how we fixed them. So the first thing we had was secrets all over the place. We had about 8 different secrets that had to be populated manually for each environment. So we have public and private servers in both prod, staging, and a dev environment. And so we had 8 secrets for all of those. You had to generate them separately, and there's really no common place to get them from. Our favorite method of sharing was sticky note and passing it and hoping they'd throw it in a fire after they were done. So we wanted to get out of that method of sharing secrets around. And we also had dozens of manual changes required for each one. All the files were very close to each other, and so you had to just change a little bit for each one, for public, for private, for staging, for dev. And that also led to our copy-paste reuse, where we copy-pasted a lot of the code and changed just those little things. This was especially with the Jenkins agents that we have spun up because they're very close to each other. Just need some very small changes for each environment. And we had it to the point where no one person could pick it up and run it. My coworker who's actually in the audience, I had done a lot of the Jenkins work. He couldn't get it working for the life of him. He'd done most of the Cassandra work. I couldn't get Cassandra working for the life of me, even though we could do it just fine on our own at our laptops. And so to solve that, cue your old friend configuration management. I don't know about all of you, but for me at least, my initial thought when you start doing the whole orchestration of containers is like, hey, I don't have to spin up whole clusters anymore. I don't have to do all the Ansible configuration or Puppet or Chef and apply all these things because I'm not spinning up a whole server. It's just a container. And I learned that was wrong. In our case, we use Ansible. And we use that because it has the ability to encrypt secrets and keep them with the repo, and also to template things really well. And so just an example of what that looks like is right here. This is like what the playbook file looks like. We have specific templates that we're using for our secrets and for the namespace that we're creating. And it's all copied into a specific path that we set up above that's not in this code snippet. And it creates all those files in a build directory that we're then able to use to spin up Jenkins. And this is what it looks like. So this is just a snippet of inside of a configuration file for Kubernetes. So we're able to configure our limits and requests, and also the Jenkins type, so public or private, and whether or not we're using a persistent disk, which we use for our staging and prod, or something like dev, where we use our empty directory. And just as an example, I'll actually show this. So this makes it so easy to deploy Jenkins, and I'll just show an example. So in this case, because I'm in a dev environment, I'm actually adding a namespace suffix, so we can dynamically change what namespace we're putting these into, and I'm populating the files for Jenkins. And so it just takes a little bit, but basically it's going through and running all that different code, skipping some of the stuff that we don't need for the dev environment, and creating the different deploy scripts and configuration files for Kubernetes as it goes through here. And you can see it going through, now it's done. Now all I have to do to spin it up is deploy Jenkins dev. And so now it goes through and you can see it running all the commands, exactly what it's creating, and bam, it's all created, all ready to go, and we can actually watch it. So I'm going to look for all of our Jenkins pods, and you'll actually see other people who work on the team, but you can see all the ones that have spun up with my name on it, and it's on container creating and running in different ready statuses, but once Jenkins spins up, it's all up in about 1 minute to 2 minutes every single time. Makes deployments extremely easy. Now this is what came from having configuration management. I really don't care what people use, like if you want to use Ansible or Puppet or Chef or whatever, this is something that really helped us kind of bring that chaos under control and have something repeatable. It also helped us in testing, which I'll show a little bit later. So the next thing we get to is, now that we had things working, are things actually working? We could deploy things and then an hour later, or sometimes the next day, find out it was running in a degraded state for 24 hours. So Kubernetes can even say that something is running, but how do we know that things are actually running? And so I'm going to go over how we managed to do this. We did it with monitoring tools, readiness probes, and a lot of testing. So the first thing is with monitoring. We did 3 different things here. The first is node and application information using Snap. And so Snap is basically doing, let's see, it's that one. No, it's the next one. So Snap, like I explained earlier, allows us to gather data pretty much from any source. So it's running on these nodes, gathering all the data and publishing it into Heapster. We're using that with, we're publishing that in InfluxDB along with Capacitor, which is another tool by Influx that allows us to do stream processing and, for example, publish an alert when the CPU goes above 2 standard deviations of its normal. And so, once again, your tool can work with whatever you want. If you have another tool you're using, there's other databases that Snap supports. But in our case, we found Capacitor to be very helpful to give us those alerts when things were going wrong with the nodes. We also used Elasticsearch with FluentD. I'll have a link with that at the end. That's actually an add-on to the Kubernetes cluster you can spin it up with. And we used a handy tool that we found. It's an open source tool by, I think, Yelp called ElastAlert. And ElastAlert allows you to do just Elasticsearch queries and alert based on spikes of CPU or blacklists. If they see a certain value that's not supposed to be there, it alerts for you. That's also very handy, and that's actually where we get a lot of our alerting from. We know if something goes wrong with Jenkins because we get a bunch of severe exceptions in the logs. And so that helps us monitor things through the logs as well. Now, the last thing we did is we built just a pretty drop-dead simple pod monitor. It's a Python script inside of a container that's running. And it uses and leverages label queries. But I'll show what's going on here. So once we get a list of pods from the API, we can actually use this little block of code where we loop over the container statuses. Because inside of a pod, your pod can be running, but the containers are not actually running. A running pod means the pod has been scheduled and the containers are created. And that's all it means. You can even look at it in the documentation. There's a stern warning in there about that. And so what you can do with this is you can actually loop through each container status. So we first check to see if the status is not running in the pod, because if it's not running, then obviously it's not ready. But then we check each container inside of the pod to see if that pod is ready, and then we start adding data into basically a small object that we have that shows exactly which containers are broken and which namespace they're in and a couple other details. And so I actually have a full script of this, which I'll show a link to at the end, so you can see how we're doing that. Now, how we're getting that information is using this little function right here, where we pass in deploy types. All of our files have a deploy type label that labeled the application name. So in our case, we have Jenkins and Cassandra and Snap and a couple other things. And so it goes through here and just joins all the deploy types into a string into a label query. Now, to make that a little bit clearer what it looks like if I'm just using it as a normal command, it looks like this. So right here, you can actually use set-based matches with label queries. And this is very helpful for monitoring and debugging. So right now we're saying I'm looking for any pod with a deploy type where the deploy type value is Jenkins or Cassandra. And it has another label in there where app is equal to master. And so you can join a bunch of these together to do some really complex queries and find out what's going on. So readiness probes. This is actually one of the favorite things I've done in terms of monitoring because it's so simple. There's just some gotchas that we'll talk about. So there's liveness probes, and liveness probes will kill your pod if they return false. Basically, if they show that it's not working, it'll kill your pod and restart it. That's not the behavior we wanted, especially with Jenkins, because Jenkins could be not ready, but still, like, we don't want to kill a running job that's on an agent or something else that's going on. And so the readiness probes are what trigger back to that code I was showing earlier with the pods or the containers in a pod being in a ready state. In our case, this is just a simple cat of a file that we put on the file system once Jenkins is up and ready. And you can also do an HTTP GET instead of an exec. That documentation is available. And then you have an initial delay seconds. In our case, we wait about 15 seconds for Jenkins to have some time to spin up, because we've never seen it spin up really faster than that. And so once that's running, it just keeps running out, and it'll tell you if it's failed or not. And it'll actually show up in the kubectl describe pods. It'll show it as an event that occurs, that it failed that check and how many times. Now, just a note, if a service is not, if a container is not in a ready state, a service cannot forward traffic to it. That's actually good, because we don't want that to happen. With us in Jenkins, like, we don't want the jobs going to the Jenkins server and the Jenkins server is not ready to receive them. And so this works great. However, when you get to things that require state, whether you're doing it in a pet set or a deployment, in our case it was Cassandra. And what happened with ours is I did this in Jenkins. I was like, wow, that was easy. And I went over to Cassandra and created a Cassandra readiness probe. And then all of a sudden, Cassandra just would die. And I was like, okay, why is it dying? And I found out it was because the service, it wasn't forwarding the traffic for the inner cluster communication, for it to spin up and set up the cluster. So after a little bit of digging, I found this right there. This is your friend, in case you're using readiness probes. It is an annotation that you can add in that says you can tolerate unready endpoints. And you can see these are the intranode it should be inter, not intra, but internode communication ports right here that allow it to set up its cluster. And we've only exposed those without the service being ready. But then once the service is up, then the other one that allows CQLSH to connect allows the traffic to go through to Cassandra. So the other thing we did was testing. Now, I know that sounds stupid. Believe it or not, testing is important even inside of Kubernetes. There are a couple times we brought things down when we launched them because we didn't have a gating test for our different Kubernetes files and the different images we've created. And so after we learned that, we decided, okay, we need to get these gating tests and get them working. And so these actually do a full deploy of Jenkins or Cassandra or Snap on Kubernetes. So it's actually just running, it's Kubernetes spinning up it's Jenkins running on Kubernetes spinning up Jenkins. And so it works really well for those unit tests. Now, Kubernetes makes this really easy because of that kube control, the ability to access the API and do other things inside of a pod. Now, because we had automated things, it actually made it really easy. And I'll show you what that job looks like. I know this is actually, let me see if I can zoom in. So right here, you can actually see that it's pulling down the Git changes that we had, just like you'd expect in Jenkins. But once it's pulled everything, it comes down here and it actually creates a random namespace to contain everything. And it creates, using a deployment we've created. So this is a test for an InfluxDB Snap plugin. And it creates a service and then waits for it to come up and checks to make sure all the pods are ready. And once all the pods are ready, it actually runs that command inside of the specified container and runs these. In this case, it's running the Go unit tests for this to make sure everything's running. And then it succeeds and cleans up that namespace that was created. That's all done because we just have that kube control installed, and that agent of Jenkins inside Jenkins can run and spin up the necessary containers for things to work. So, just in review about what we went over. So the first thing is just design your containers well. You can also deal with designing your application well, but just make sure your containers are designed well and can work inside of Kubernetes. Know how to use the API. It will be your friend because you can either use it inside. We actually found out talking to the etcd people that their operator stuff is using the API to make sure they set up everything. You will have to do this at some point as you create more applications that you're going to be running in Kubernetes. Don't forget the role of config management. Make sure you are monitoring and testing all the things. Know the gotchas, some of these different examples we gave, and then just one last problem to go over. The need to document. There's actually been some mention about the state of documentation inside of Kubernetes. Now, actually, I find the documentation useful, but there's still some big gaps. So I'm hoping that you guys at least learn one thing from this that can help you with some of your deployments. But I just wanted to share an example of why this documentation is important. So that example I gave of the tolerate unready endpoints. So that came after a lot of research. So after I discovered that Cassandra had gone down, first I had to figure out it wasn't a problem with Cassandra or something else I upgraded. That took about an hour or so, and I'm like, okay, so it can't connect to the service. But then for the next half of the day, I had to search around. I was Googling, and you didn't know what term to search for, and I'm looking for all these different things. And finally, I found one issue that hooked to another issue that hooked to a PR that had that code in it. There's no documentation on it. And so that's what we're trying to avoid here, is we're all trying to get these things spinning up in production, and it's very helpful if we share what we've done and document what we've done. So my invitation is that we can make this running of production applications in Kubernetes much easier by documenting. And to start off, I created a blog post with my team that has all these code snippets and more about what we did. I mean, it is chock full of code snippets. And you can go visit that, along with some other posts. We have some things about kubesnap, which I'll show here. And we'll get to questions, but these are the other links that I was talking about. If you want to see more about how we run Snap in Kubernetes, you can go to kube.snap-telemetry.io. And then that's the code inside of the add-ons for the Kubernetes repo for the Elasticsearch with FluentD. So with that, are there any questions?
And if you could come up and use the mic so that we can get it on the recording. Nobody.
Wow, either I did really good or did you have a question?
Really good. Charts on web? Or
Which thing?
the charts for the presentation?
Yeah, so all these are on, this presentation is online on the event for this. You can download these and actually get all the different code. And as I said, this blog has the detailed examples of everything I showed in here plus more. So you can go on there and see and just start documenting and sharing these things around, because we could use it, and I'm hoping you guys have been able to use this. And by helping each other out, we'll kind of improve that documentation that we have and be able to make it easy for people to run these things in production. So, well, thank you.